Alright, so today we'll look at parametric equations of a circle. So now we can also define a circle as the locus of all points that satisfy the equations x minus a is equal to r cos theta or y minus b is equal to r sin theta, where x and y are the coordinates of any point on the circle. R is the radius of the circle and theta is the parameter, the angle subtended by the point at the circle's center. So now in case this is the circle that we actually had, so this is an example of a circle that is actually drawn with the center being at the origin. So this is the circle that we actually have. So you can actually see that the angle subtended by the center is actually the theta value right there. Then here we are assuming that the center is at the origin 0, 0, and this is what we have. So therefore this point here shall be equal to r cos theta, and then this point here shall also be equal to r sin theta. So this is what we have in this example. So now when the center is at the origin, we can actually see that x minus 0 shall be equal to r cos theta. Alright, so when the center is at the origin, as you can look at here, when we say x minus a is equal to r cos theta, this time the value of a is 0. So x minus 0 is equal to r cos theta, and we shall have x being equal to r cos theta. So x is equal to r cos theta when the center is at the origin. And then we can also see that y minus b, which is r sin theta, now the value of b is also going to be equal to 0. So y minus 0 shall be equal to y, of which y shall be equal to r sin theta. Now what does this mean about the equation of the circle? Now the equation of the circle, which you remember is usually x minus a squared plus y minus b squared is equal to r squared. Now since a and b are 0, we shall have the equation of the circle, in this case when the center is at the origin, being equal to x squared plus y squared being equal to r squared. So this is the equation of the circle in this case when the center is at the origin. Alright, so how about when the center is at another point other than the origin? So now this is an example of a circle whose center is not at the origin. So this is what we have. So now these are going to be presenting points A and points B on the x and y axis. So this is what we'll now have. So as you can see, to get the coordinates of P, we shall now look at it this way. So now to move from here to this point right here on the horizontal is going to be equal to A plus r cos theta. And then to move from this point here to this point here, it shall be equal to this value of b plus r sin theta. So that's going to be the coordinates of the y-axis for the p, as you can see right there. So therefore in this case, x shall be equal to a plus r cos theta, and then y shall be equal to b plus r sin theta. So now we can see that if we make r the subject in the first one, r shall be equal to x minus a over cos theta, and then in the second one, r shall be equal to y minus b over sin theta. So therefore we can see that r is either equal to x minus a over cos theta, or it's equal to y minus b over sin theta, and that shall be another equation when the center is not at the origin. Alright, so in general, when given a circle x minus a squared plus y minus b squared is equal to r squared, the parametric equations of the circle are x is equal to a plus r cos theta, or y is equal to b plus r sin theta. So let's look at some examples, and this will actually give us a better understanding of whatever we're talking about. So in part 1, we're being told to find the equation of the circle. The equation of the circle is x minus 4 squared plus y minus 3 bracket squared is equal to 4. Alright, so when I look at this equation of the circle, I can already say that the 4 represents the a. So we can say that x minus a shall be equal to r cos theta, of which x shall be equal to 4 plus r cos theta. Then I can also see that the value of b is 3, so y minus 3 is going to be equal to r sin theta, of which y shall be equal to 3 plus r sin theta. But remember that also r squared from here shall be equal to 4. So therefore, if we find the value of r shall be equal to 2. So now that I know that r is 2, I can actually substitute this value of 2 into this here, where we have y, and also here where we have x. So therefore the parametric equations of the circle shall be x is equal to 4 plus 2 cos theta and y is equal to 3 plus 2 sin theta, and those are the answers. Question 2. Find the parametric equation of the circle x plus 1 bracket squared plus y minus 2 bracket squared is equal to 9. So here also I can also see that what we have is this. Now as I can see here that the value of a now in this case shall actually be equal to -1. And why is that? It's because the equation of the circle is naturally supposed to be x minus a, but since this is a positive one, it means that the value of a is -1. So that means a is equal to -1. And then we can also see that here b shall be equal to 2. Now here it's y minus b, of which we can actually just have the b as 2. Now it means that x plus 1 shall be equal to r cos theta, of which instead of x minus 1, it's now x plus 1, of which x shall be equal to r cos theta minus 1. Then you can say that y minus 2 shall be equal to r sin theta, of which y shall be equal to 2 plus r sin theta. Now when we solve for r squared is equal to 9, we shall get r being equal to 3. So plug in the value of 3, r here, and we shall have the parametric equations of the circle being equal to x is equal to 3 cos theta minus 1 and y is equal to 2 plus 3 sin theta, and those are the answers. Question 3. Find the parametric equation of the circle x squared plus y squared minus 4x minus 2y plus 1 is equal to 0. So how do we do this? So first of all, we have to actually convert this into the general equation of the circle. Now in this case, we've been given this equation in Cartesian form, and now we're going to put it back into the general equation of the circle. So do that by completing squares. When you complete squares, this is what we'll have, and eventually we'll have x minus 2 squared plus y minus 1 squared being equal to 4. And then we can now actually see that x minus 2 shall be equal to r cos theta, of which x shall be equal to 2 plus r cos theta. Then also we shall see that y minus 1 is equal to r sin theta, of which y shall be equal to 1 plus r sin theta. Then we can say that r squared is equal to 4, of which r shall eventually be equal to 2. So plug in that value of r into x and y, and we will have, so we shall have x being equal to 2 plus 2 cos theta and y being equal to 1 plus 2 sin theta, and those are the parametric equations of this circle. Alright, so the next question is a question from UNEB 2013, and this was question number 3. So being told that given that r is equal to 3 cos theta is an equation of a circle, find its Cartesian form. So in this case, we've been told that r is equal to 3 cos theta. So how do we solve such numbers? So do you remember when we said that when the center is at the origin, that x shall be equal to r cos theta and y shall be equal to r sin theta, and therefore the equation of the circle is equal to x squared plus y squared is equal to r squared? Yes, we shall be using the knowledge that we actually derived in this section. Alright, so we have r is equal to 3 cos theta as the equation of the circle. So the first step shall be to multiply through by r. So when I do that, I'll have r squared is equal to 3r cos theta. And then next, I'm going to convert into the Cartesian form using x is equal to r cos theta, y is equal to r sin theta, and x squared plus y squared is equal to r squared. So substitute those, and this is what I'll have. So whether it's r squared, I'm going to substitute that with x squared plus y squared. And then next, I can see that we have r cos theta here, but remember that r cos theta shall be equal to x. So therefore, this is what I have x squared plus y squared being equal to 3x. So bring the 3x to the left hand side, and I'll have x squared plus y squared minus 3x is equal to 0. So therefore, the Cartesian equation for the circle r is equal to 3 cos theta is x squared plus y squared minus 3x is equal to 0, and that is the answer. Alright, so the next question is question 6. Given that r is equal to 3 cos theta plus 4 sin theta is an equation of a circle, find the Cartesian form of the equation of the circle and its coordinates of the center. Alright, so this is the equation of the circle that we've been given. So first step, we're going to multiply through by r, and we'll have r squared is equal to 3r cos theta plus 4r sin theta. Then we're going to convert into the Cartesian form using x is equal to r cos theta, y is equal to r sin theta, and x squared plus y squared is equal to r squared. So first of all, we can say that where we have r squared, we can actually substitute that with x squared plus y squared. Then this is what we'll have. Then we can also see that r cos theta shall be equal to x, and then r sin theta shall be equal to y. So when I plug on those in, this is what I'll have. So now when I bring this to the left hand side, I'll have the Cartesian equation of this circle shall be x squared plus y squared minus 3x minus 4y shall be equal to 0. Now, very important, we are not only told the Cartesian form of the equation of the circle, we're also told to find the coordinates of the center. How do we do that? We're going to compare with the Cartesian equation of the circle with the general equation of the Cartesian form that was given. So this is what we have. So when you compare with this, we shall see that 2g shall be equal to -3, of which g shall be equal to -3/2. We can also say that 2f is equal to -4. So f shall be equal to -2. So therefore the center of the circle, which is given as -g, -f, shall be 3/2, +2. And this is the center of the circle. Question 7. Given that r is equal to 12 cos theta plus 5 sin theta is an equation of a circle, find the Cartesian form of the equation of the circle and its radius. So now this is the equation of the circle that we have. So now we're going to first multiply through by r, and this is what we have. We'll have r squared being equal to 12r cos theta plus 5r sin theta. So we're going to convert into the Cartesian form using the knowledge of x is equal to r cos theta and y is equal to r sin theta, and then also x squared plus y squared is equal to r squared. So when I plug those in, where there is r squared, I have x squared plus y squared. This is what I have. Then remember that r cos theta is equal to x and r sin theta is equal to y. So I have x squared plus y squared being equal to 12x plus 5y. So when I move this to the left hand side of the equal sign, I'll have x squared plus y squared minus 12x minus 5y is equal to 0 as the Cartesian form of the equation of the circle. But we've been told to find its radius. So first of all, we're going to compare this with the Cartesian form of the equation of the circle. So now we shall see that 2g shall be equal to -12, of which g shall be equal to -6. Then you can also see that 2f shall be equal to -5, of which f shall be equal to -5/2. And then we can also see that c is equal to 0, because actually here it's actually not given, or it's missing, so it's actually equal to 0. So therefore the radius of the circle, which is given by r, is equal to root of g squared plus f squared minus c, shall be given as that. So when I solve that, I'll have root of 169/4, which shall give me 13/2 units, and that shall be the radius of this circle. Alright, so lastly I have an exercise for you. So this exercise will prove to you how much you've understood whatever I've taught in this part of the video of parametric equations of a circle. So I encourage you to try this out in your free time, compare your answers to what I have given, and then get better. Thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. If it did, feel free to share the video with all your friends and help as many as you can. And then if you really like the video, feel free to give the video a like or a thumbs up, and then tell me in the comments if the video really helped you, and I'll try to get time and reply to your comments. And then if you're new to this channel, I encourage you to join the community by subscribing, and then make sure to hit the notification bell so that you get updated every single time I upload a new video. Thank you so much for watching, and I'll see you in my next video.